Good afternoon. Hi, guys. Yeah, I'm here to talk to you about how we developed a way to fully automate our Zabbix installs. And this came about because, well, there's a lot of different Zabbix machines that we are currently using, and well, I'd like to explain how we did it, why we did it, and what you might learn from our experiences. So. There we go. First, a bit about me. My name is Raymond Kuiper. You can find me on Twitter, LinkedIn, and on GitHub. As mentioned, I've been using Zabbix since 2006, starting with version 1.13. I'm a network/system administrator, and yeah, well, I've been working with Zabbix and network-related stuff, yeah, for years now. I work for a company called Netco. We are a infrastructure network provider, which basically means that we build and maintain networks for various customers. A couple of years back, we started doing networks for retailers. So basically the bigger shop brands that you might have in your country, they have a lot of locations, sometimes up to hundreds of different sites. And they need networks, wide area networks, to interconnect all of those devices that they have. And also, they want to connect into networks for third parties, like suppliers or maybe like head offices, that kind of stuff. So they need a centralized wide area network to manage all of their network traffic. We started building those networks, and actually it was such a popular solution that we started putting into the market, and we actually branded it as a separate solution. So we sell it under the name of the retail stacker, which in Dutch basically means a retail plug, as in we can plug your locations into your network and take care of all of that stuff and manage it for you. So those customers will do, payment transactions, maybe printing or point of sale devices are all interconnected into that network. Basically, the tech stack that we use to build these retail stacker networks are based on all of these technical components. We do some Python stuff. Yeah, most of the products that you can see here should be familiar for most people. And we use SaltStack as our main automation engine and orchestration tool. The things that I'm going to talk about in this presentation are based on SaltStack, but I'm trying to do this presentation in such a high-level overview that you should be able to do the same things more or less with Ansible or Puppet or whatever other tool that you're using in your organization. So, basically, a retail stacker network consists of like hundreds of locations, and all of those locations have a router device. Typically, in our case, that's going to be a Cisco router. Of course, all of these routers build a wide area network, and that's connected into our central data center. And we have a central firewall there that will actually secure all of the incoming and outgoing connections for those networks. And then from there, we can build a link to your head office or maybe to a third-party supplier, and we can also provide VPN access to your users so that they can access all of the devices on site, on-prem. Now, of course, to be able to actually use this, we have a tech stack supporting this. So we use FreeRadius for authentication of the locations. We use DHCP and Bind to provide network services to the locations of the customers. And of course, everything is going to be monitored by Zabbix for such a customer. And then on top of Zabbix, we actually build a Django-based dashboard that the customer uses to actually get an insight in their current network status. Now, this is the dashboard that we've built. As you can see, here you can see the number of locations for this customer that are currently running on a normal DSL or fiber uplink. We also offer 4G fallback, so LTE. And as you can see, some of the locations in this case are running on a 4G fallback location connection because probably the primary interconnect, the fiber or the DSL, is offline or hasn't been delivered yet. A couple of locations are offline. Some, well, currently for this customer, none are planned. And we have a couple of unknown locations. And as you can see, we make a topographical map of all of the locations that are in use. And according to the color, you can actually see the status for each site. Then if the customer wants to know more specific details about what's going on a certain site, they can actually click on it, and they'll be able to see the LED status of the device that's on location, the amount of data that they are using on their 4G connection, all that kind of stuff. And they can also run some diagnostics on the location as well. In this case, the location is running on cellular, and it's actually using data for the last couple of days. And this way, the customer can keep an eye on their data usage, because of course 4G is a paid subscription. And then since a couple of months, we also integrated third-party monitoring into the dashboard. So now, when a customer has suppliers that they need to keep in contact with over a VPN tunnel or something like that, we can actually do Zabbix monitoring, and they can quickly see the status of the specific suppliers, if there's problems or not. And in that way, we have a high-level overview of if these connections are in order or not. So, all of these customer locations are interconnected to the wide area network, as I mentioned, and the wide area network is monitored by Zabbix. But each customer actually gets their own network and their own Zabbix server. So we have multiple of these setups. To keep an eye on all of the Zabbix servers from our NOC, from our engineering department, we use Grafana as a sort of unifying dashboard to fetch all of the metrics and see all of the alerts in all of those Zabbix servers. So the dashboards that we use, they actually monitor the number of VPN nodes that are currently up, and the number that is down or in maintenance currently. And as you can see, we also put all of the alerts for all of the Zabbix servers in one screen. And then, of course, we also actually monitor the Zabbix servers themselves from Zabbix. So as you can see here, we have each column is a Zabbix server, and you can see all of the processes and cache data, all that kind of stuff, the number of items unsupported. So this is the way that we keep an eye on all of those Zabbix instances that we are building for those customers. So now on to the fun part. This was just a bit of a background that you know why are we doing this and what's the reasoning behind having so many Zabbix servers, because we want to have each customer to actually have its own Zabbix server. Now, so of course, if you have tens of Zabbix servers, more than 10, it's going to be a hassle to maintain that all by hand. So we've set up all of the automation to basically fix, install the Zabbix server, configure the Zabbix server, and then even tune the Zabbix server fully automatically. So for the installation, we actually wrote a little script in Python, and this script basically asks for a couple of things. So it wants to know the customer name, a specific environment number that we use to differentiate between the different customers. And it will also ask us for certain IP addresses and all that kind of stuff. And it will automatically generate all of the passwords that are going to be used in the environment. Now, once we input all of the data into this script and we say, okay, deploy this customer, our salt stack server will start talking to one of our KVM machines. And the KVM machine will then start up a Zabbix instance, among other things. But we're here to talk about Zabbix, so this is the most important one for this talk. Once the Zabbix server is booted, it will contact the salt stack server, as it's an agent-server-based relationship. And the salt stack server will tell the Zabbix server, okay, you need to register with Catallo, which is our package management system. And you will need to register yourself with FreeIPA as well. That's our IDM, so the LDAP system that we use. And from there, it will start installing all of the Zabbix software. Then, once that's done, we also pull in our custom code that we need from GitLab. This is just synced to the local disk. Well, that leaves us with a installed Zabbix server. I think most of you will probably have used Ansible to do something more or less the same as well. Now, from here on out, we actually want to start digging into the Zabbix system itself and start configuring it fully automatically. So what we do, one of the first things that we do, of course, like I said, we use IPA, free IPA as an authentication mechanism for our servers. And we want to be able to use LDAP as a backend for our users as well, so that they can use their normal password. Now, to be able to do this, the only way I found currently is that you need to do a SQL update. So if you supply a SQL update, and we run this from SaltStack, from that moment on, you can actually use LDAP from the web interface for Zabbix. The thing that I would like to see is that we can actually use an API call to enable LDAP authentication, which would be good. So there's a Zabbix Next for that. So if anybody agrees with me, please vote for this issue. So then, of course, we have basically an authentication backend. So now we want to define some media. And we also use SaltStack for this. So we just have a little SaltStack file which tells the server, okay, you need to set up an email media type. And then we come to the user groups. So for each, we have different types of user groups that we use. So one is basically just for API users that we have for interconnecting from different other systems into Zabbix. So for instance, the dashboard that we're actually using. The support group is for our engineers, so that they can log into Zabbix and troubleshoot some stuff directly into the front end. And then we have a user group that we use to actually give the customers access to Zabbix. But of course, the customers are actually using our dashboard instead of the actual Zabbix front end. But we use this to do things like assign media types and all that kind of stuff for those users. For one of the things that a lot of people that are using Zabbix with LDAP will find out is that the user still needs to be created in the Zabbix front end, which is a bit of a hassle. So we've automated that by actually using a little salt command that uses getEnd to fetch all of the users in the Zabbix user group. And then, as you can see, it basically does a for loop around all of those users, and it will automatically create the user in Zabbix for us. So we don't have to create users manually anymore, even though they are still in LDAP. So then after that, SaltStack will actually install all of the external scripts and also the notification scripts that we use, and we basically use a Git repository for this. So all of the scripts that we develop for external checks and all of the scripts that we use for notifications are stored in the same internal GitLab repository, and then we just pull that in and put it on the disk. So that means that once a new version of the script is committed, it's automatically deployed to all of the servers once there's a salt run. We use the same kind of trick for synchronizing our template. So every time we develop a template, we put the template in the GitHub repository, and with the next SaltStack run on that server, actually the Git repo is going to be pulled into the local file system on the server disk, and then if it actually changes, then we'll run a little template script that will, a little Python script that will import all of the templates, and it will do that recursively. So by using directories with a certain structure, we know which templates will be loaded first, and then we can import various levels of templates recursively. So if you have one template that uses another template interlinked, we first we walk through the directories in order and to make sure that the templates are all imported right in the proper order. So once this is finished, you basically have a Zabbix server that's running all of the Zabbix software, and it has all of the scripts that you need, it has all of the templates that you need, but now you still need something to monitor, right? So Zabbix without hosts, that doesn't work very well. You don't have anything that you can alert on or anything. So before we can actually add hosts, we need, of course, host groups. As you can see here, we have 2 categories of host groups that we actually push from Salt into Zabbix. Well, these are normal groups that we use for various purposes. So branches would contain any hosts that are located on branch offices. The servers are things like the Zabbix server itself that we want to monitor. Aggregates, I'll come back to later. These blue ones, the pre-deployment, maintenance, and offline, are groups that we use for maintenance. And I'm going to explain a bit more about that later as well. And then we have the device groups, which will contain all of the, in this case, switches, access points, routers, all that kind of stuff on the locations of the customer. So those are the actual shops, the retail locations. Now, one way that we can add hosts to Zabbix is by just using SaltStack again. And we define a host in SaltStack, and each host that we define for that customer will actually be created in SaltStack. And as you can see, we can also push macros and templates, and that way we can make sure that each time SaltStack runs, any host that's missing from the system will be added automatically to Zabbix. This is something that we use mostly for like branch offices or the third parties. We don't really use this for the shops because there are hundreds of shops, and this is really slow to walk through in that case. So what do we do for the shops? We wrote a Python script, which we called Info Builder, and the Python script uses an HTTP API call to our central configuration management database that we have. We wrote our own CMDB, and this CMDB contains all of the locations of all of the hardware that we have for this retail stacker product. Now, the script fetches all of the locations that are basically used for this customer. So all of these customer devices are known by the script, and the script will use that information to create our DNS records. It will create our free radius records that we need to actually authenticate the locations to the central environment. It will create DHCP. It will actually grab configuration files for the switches that we also deploy and then put that in the TFTP server. And of course, it will also talk to Zabbix. So every host that's known in the CMDB will eventually be pushed into Zabbix. If a host is removed because the contract is cancelled, it's automatically removed from Zabbix by the same script. And then there's another category of hosts that we add. We use a lot of aggregates. So SaltStack also creates an aggregate for each of the device groups that we have. So if we create a device group for routers, it will automatically create an aggregate host, which actually will start counting things like the number of routers that are actually in the group. It will start to monitor how many of those are actually responding to ping responses, and it will also start counting how many of those are in maintenance. Now, this allows us to have a high-level overview of how many of the shops are actually functioning correctly, and how many are in maintenance, and how many are not working properly, because we know there's 520. There should be 520 responding here, but they're not. So as you can see, I'm missing 2 hosts here that are down because they're still in maintenance, and that's to be expected that they don't respond to ping in this case. So that leaves us with all of the hosts that are in Zabbix. So now we have a Zabbix system that's installed, that has hosts, is monitoring stuff. But yeah, then of course you get things like tuning and all that kind of stuff. So that's why I called it housekeeping, because that's the thing that a lot of people are actually putting a lot of time and effort in. And so if you finally have your Zabbix server running, and then at some point, you have so many hosts that it's starting to have issues with I/O and stuff like that. We try to automate as much as we can in that space as well. So under housekeeping, for instance, maintenance is one of those things that you would like to automate, I think. So what did we do? We created 3 maintenances in Zabbix, which basically run forever, and they are all maintenances with data collection. So if we put a host in one of these maintenances, that will mean that it's being monitored, but it's not going to be alerting. So why did we create 3 different maintenances? Well, that's because once a host is imported through that Python script that we run, the infra builder script, that Python script actually puts it directly into the pre-deployment maintenance. That means that as soon as we get an order for a new location, we can already put it up in monitoring. So Zabbix already knows it, starts monitoring it, but it's in maintenance by default, so our engineers won't be bothered by the fact that the router is not delivered yet. So that gives us time to actually ship a router to a location, and then once it's online, we have a predefined period, which is normally 8 hours. So if a router has been up for more than 8 hours, it's automatically removed by a script from this maintenance. So that way we can just put new hardware in Zabbix and know for sure that it will start monitoring as soon as the connection is actually up. Then we have the offline maintenance. Offline maintenance is a bit special. We have a script running in the background that will check if a host has been responding to ping for a certain amount of time. If it's been down for like 7 days, that means that we are watching and looking at triggers for a host that might be down, but apparently they've been down for 7 days already, so I guess the customer isn't bothered by it. What we found out in the practice is that a lot of our customers will start, I don't know, redecorating a shop or something, turn off all of their equipment and don't inform us that they're actually doing like a redecoration or something like that. So every now and then we see shops that are down for a month, and we don't know why, but it's hogging up resources and it's hogging up indicators on your dashboard that something is wrong, which apparently it isn't. So we put them in the offline group after 7 days, and then we put the status in the dashboard, and it's unknown. We don't know what's going on here. Apparently there's an issue, but it's been going on for so long. And then at some point, when it comes back online, after a couple of hours, we remove the maintenance, and then we start monitoring it again. And then the third one is just the normal maintenance, which we use for our engineers. So if an engineer is working on an issue on a router or on a switch, he can put it into the maintenance group, and then the customer won't get any alerts for that host. And then once the engineer is done, he has to remove it from the group manually. So one of the things that I noticed is that if you have a lot of hosts that are actually not reachable, Zabbix will monitor all of the polling items on those hosts anyway. So for SNMP, we use a lot of SNMP items. So if you have a host that's being monitored with SNMP, even though it's not pingable, Zabbix will still try to read, for instance, interface metrics or system information or stuff like that. And we have thousands of SNMP items. And if you have a couple of hundred hosts that are down for some reason, Zabbix is going to spend a lot of time trying to figure out if the items are still reachable or not. So what we did is we created a little Python script that uses the API, and that checks if the device is pingable or not. And if a device is not pingable for, I don't know, like 8 hours or something, I set the threshold to, it will actually go in and disable all of the polling items for SNMP, HTTP, agent, whatever. Anything actually except for the ICMP triggers, ICMP items or the trapper items. So that means that frees up the poller, so it's no longer trying to reach a host that's not reachable anyway. And then after a couple of hours, if a host starts responding again, we turn on the items through the same script, and that restarts all of the SNMP monitoring for that host. So that's the way that we worked around resource, basically, just resource hogging for SNMP-related stuff. So if we have that retail stacker network, so basically this is a representation of the wide area network, and we have a shop for a customer, they usually have a router, and then behind that router there's a little switch. And then, for instance, behind that switch we also manage a few access points that they use for the Wi-Fi solution in the shop. Yeah, there's a dependency here. Now, of course, you'd like to have Zabbix only alert you that a router is down and not that also the switch and access points are down. But how do you manage that normally? You would actually need to define those dependencies by hand between the triggers of the devices. This is a bit of a hassle, so we wrote a little script to actually work around that problem. So what we do is, from our CMDB, we sync all of the things like contract numbers and all that kind of stuff for those locations. So every device on that location in Zabbix has an inventory field that we use to differentiate the actual location on. So now that we have the inventory field for the contract number filled, we actually know that all of these devices are on the same location, even though we don't do any network discovery or anything like that. And then based on this contract number, we know, okay, well, an access point is always going to be connected to a switch, so we can put dependencies in there. And then a switch is always dependent on a router, so we put dependencies in there as well. So the script will automatically create trigger dependencies automatically between all of these types of devices. Well, that leaves us, I think, with sending alerts to the customers. Of course, the customers want to know if something is down or not, but they can actually look at the dashboard to see if a certain location has been acting up. What they are really interested in is how, if a large portion of their locations goes down, they want to get a notification quickly. They want an SMS or a text or something like that. So what we did in the dashboard is that we defined a drop-down that they can select, and if they say, I want to be notified by a certain percentage of locations that are down for some reason, that will actually create a user macro on the aggregate host that we created. So that router aggregate host that we use to actually monitor the number of routers that are online, we create a macro on that host, and that macro is then used in the trigger that we use to actually notify the customer. So if the customer changes the drop-down to another percentage number, it will change the user macro, and then another trigger will be in effect for that customer. And then, of course, yeah, we need to send it somewhere, so the customer can define their media, and then we actually use a customer user, which is just a basic user, which hasn't got any other rights except for read rights, and that's going to be assigned with these media. So after the customer has actually inputted this into the dashboard, then actions are active that will alert them for, I don't know, 25% down. So if a lot of locations go down, they get a text message or an SMS on these media. Well, then lastly, of course, we have Zabbix running, we have alerting, but now we also want to do some reporting, of course. I think a lot of people really would like to use some kind of reporting with Zabbix. So one of the things that we figured out a little while ago was we wrote a script that we can use to create automated reports on items, item values, and also on inventory fields that we use heavily. So for instance, we have an SNP item that will pull in the serial number of a device, and that's stored in inventory as well. And then the script will run the report with a host name, for instance, output serial numbers and also any item types that we want. And we can send this report through cron every month or so to our financial department, for instance, that will know, which can use that report to cross-reference if we're actually charging the right amount of routers and for the right serial numbers and all that kind of stuff. So I don't think we're doing questions. No? Okay. So if you want to...
Telegram questions. Questions via Telegram.
Okay, great. Yeah.